This is my third video actually in the flying with physics. So the objective of this video is to show you one particular typical problem, which is a bit, having multiple theories as such amalgamated into a single problem, and what kind of approach is taken to solve such problems. So as you know that this flying with physics is mainly addressed or made for aspirants who are looking at trying to sit into physics olympiad, both at national and international level, or even for IIT advanced or IIT mains exam as well. So if you see, this is a typical problem wherein there is a two concentric cylinders, and within that two concentric cylinders initially, and there is a disk, that is here a thin disk which is of mass m, and it is kept at a distance h from the ground. And what is happening, the inner cylinder is actually charged with a surface charge density of lambda, and the outer cylinder is grounded or earthed. So this is the initial setup that is there, which is step 1. As you can see, suddenly what is happening, this annular space that is here is being filled with a dielectric gas. Now this dielectric gas has a dielectric constant k, which varies with the distance r, as you can see, k0 r square. Okay, and as soon as this new dielectric gas has been introduced, okay, which is having a gas constant of r in Boltzmann constant r, which is there in the next page, and it is also maintained in a fixed temperature T, as you can see. But due to this introduction of this gas, what is happening, suddenly this disk moves up by a distance x. Okay, the thin disk. The thin disk also has a mass m. Why this movement? First of all, as you can see, when you are charging this cylinder and you are grounding the outer cylinder, this will actually create an electrostatic system. Now this electrostatic system will have some energy due to this, because it will form a capacitance, and that capacitance will form an energy. And when you introduce this gas, what will happen, this energy will suddenly change. Okay, where do this change in energy will go? So basically this change in energy will create an heat within the system. Now because the temperature is maintained at the fixed temperature here, that heat is going to cause some isothermal change within the gas. Okay, because it is in the same temperature, so temperature is not changing. Now what is happening, because due to this isothermal change and the heat being constant, okay, basically it is moving. So due to this change, what is happening, because there is a heat that is heat getting generated, and that heat will actually move this disk. Okay, and then ultimately how much distance it will move, that is what we have to actually bring out. So if we do the calculations, and if we bring in all the properties or concepts of physics, which actually how the electrostatic energy getting transferred from the capacitance, because that will create a capacitance. So that capacitance will have energy, which is sort of electrostatic potential energy, and that potential energy will change because of the sudden change of that introduction of that gas, and that potential energy in turn will cause an heat. Though the temperature is fixed, the temperature is not changing, so what that heat will do, it will impose that disk to go up. Okay, and if you solve with all those different properties or concepts, then you will get an equation like this, which will actually form the solution for x, how much distance it is moving. Okay, and this is the equation that you can see. And if you solve this equation, and this is the other part, sorry, I cannot put it in a single page. So this is the left hand side, and this is the right hand side of the equation. And if you do a solution of this equation, you cannot do a kind of exact solution, because this will ultimately turn into some kind of a series, infinite series. But considering this distance movement x will be substantially less compared to the actual this height h, okay, there is an approximate solution that can be brought over, and this approximate solution will be this one. X will be approximately following this particular thing. Okay, and now just to provide, there are certain variables that you can see here. So h is the distance, as you can see, the initial position where this disk is there, this is h. This is moved by a distance x. Okay, and the inner radius is r1, the outer radius is r2. Okay, the inner cylinder is charged with lambda, whereas the outer cylinder is earthed, grounded. Okay, and the whole cylinder height of the cylinder is h. Okay, so this is the setup, and from there only these variables are coming. Now n is the gas constant of the gas that is introduced, r is the Boltzmann constant, T is the temperature at which it is maintained, the fixed temperature, because this will ultimately undergo a isothermal process, as I said. Okay, so this is a kind of a typical problem which involves, like you can understand, this involves both concepts of electrostatics, concepts of heat, particularly thermodynamics. Okay, and that's what is actually kind of amalgamated to create such, appear into or achieve the solution. So I'll end here for this video, but as I have mentioned in my previous video, these are different problems which I have been compiling by my own, and not only that, I have actually, it's like a booklet which I have with myself, and that booklet contains around 80-90 problems, actually more than that. Okay, I'm just giving a rough number, it's more than that, and these are all of these standards, which is quite complex. Okay, and you typically get this kind of problems if you are appearing for National Physics Olympiad or even IIT Advanced. So this gives you a flavor. This actually will, if you are practicing this is going to kind of bring the thought process in you to think from the different aspects, from the different concepts of physics, and how they can be applied together. Okay, that's important. Of course, this needs a very clear and clear-cut understanding on the concepts. This needs a good amount of understanding on mathematics, as you can understand here. And eventually, these are the kind of only specific to Physics Olympiad or IIT Advanced. But as I said in my previous videos also, it's just not stop here. I also actually kind of provide very advanced training on some additional things like AI/ML, quantum computing, and a bit of electronics also, which is mostly from the solid state physics, how a VLSI design can be done from those aspects. Because ultimately, if you go into deep, these all are based on different concepts of physics put in together. Okay, well, AI is not completely physics, it's maths and physics together, but again, it is also kind of derived from physics as well in some of the things. So I'll end here. Please subscribe to this video, and you can like and comment here. If anyone wants to contact, please comment in my YouTube channel. I'll touch base with those persons, and this is not just a YouTube channel, I'll do actually also provide coaching both online and offline. Okay, offline at my own residence, and online is through different, live online medium, I would say, not through YouTube. So if anyone is interested, I can do that. Even the booklet that I said, that booklet can be also kind of procured separately with certain charge, which is very nominal. And that booklet contains, there are two parts to that booklet. One is basically the questions that I said about, which contains a various different level of questions that you, physics problems, or physics questions, I would say, which you get in Physics Olympiad or IIT Advanced. And the solutions is a different booklet, because if I keep the solution along with the problem in the same booklet, nobody will actually go and dig into their head and try to bring the concept on their own. So that's why the solution is separate, and that's the objective. So thank you everyone.